Good morning. Today we are going to cover the binomial theorem. So this is a fun theorem, but before we get into it, we're going to first just kind of explore a little bit. So first of all, it says complete each expansion of x plus y to the nth power for the given values of n. So anything to the 0 power, hopefully you remember, is equal to 1. Oh, hang on one sec. Okay, so anything to the 0 power is 1. X plus y to the first power is just x plus y. X plus y to the second power is x plus y times x plus y. So we know that's x squared plus xy, so plus 2xy plus y squared. And then x plus 3 cubed would be x plus y times x plus y times x plus y. So that would be x squared plus 2xy plus y squared. And then all of that again times x plus y. So I'll go ahead and save you the trouble of having to do that, but it's x cubed plus 3x squared y plus 3xy squared plus y cubed. All right, and then the last one, x plus y to the fourth, would be x plus y times x plus y times x plus y times x plus y. So I've already done that for you, and you would end up with x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. All right, so make sure you wrote that down on your paper, because you're going to need that information for the next set of questions. All right, so what did you notice about the number of terms in each expansion? So if you go back over here, I've got one term here. I've got 2 terms here, 3 terms here, 4 terms here. All right, so compare that to the n here, the power. So 1 term, 0 power, 2 terms, 1 power, 3 terms, second power, 4 terms, third power. So hopefully you notice that there is one more term than the n value, the nth value. So what do we notice about the exponents on x and the exponents on y? All right, let's go back and look here. So these exponents are 1. Here we've got 2 and 2, and then what's 1 plus 1? Again, 2. Here we've got a cube and a cube. 2 plus 1 is 3. 1 plus 2 is 3, so they're all 3. And then we've got 4, 4, 2 plus 2 is 4, 3 plus 1 is 4, 1 plus 3 is 4. So hopefully you notice there that they are the same, I guess, in value at the beginning and end of the expansion. So if you notice, we started with 1 and ended with 1, started with 2, ended with 2, started with 3, ended with 3, started with 4, ended with 4. And then what did you notice about the sum of the exponents? They all added up to that nth power. And then what did you notice about the coefficients of the terms? Well, let's go back over here and look. The coefficients of each term. So we've got 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Well, they all began and ended with 1. right, so these, this is called the Binomial Theorem. It states that the coefficients of a binomial expansion are called binomial coefficients. To find them, you can use this theorem. For any whole number n, the binomial expansion of x plus y to the nth power is given by this formula. So it looks a little on the weird, complicated side, but let me kind of explain what this is. It's NCR. So what this means, this is a combination. And then the n would be given by that. And then the r would be whatever, let's say, specific term that you're looking for. So if you look on your calculator, if you have the TI-84 or TI-89, you can find what a combination of something is. So let's say we have 4 people. Well, say we have 4 seats and we're trying to arrange, I don't know, 2 people in an arrangement. What are all the different ways you can arrange it? So this is called a combination. So C42 is what you're looking for. It means you have 4 seats, 2 people. How many ways could we arrange those 2 people in those 4 seats? It's called a combination. So your calculator will do this for you if you have one of those. It's, let's see, you would type in 4, and then you would hit the math button, and then you scroll over to, let me just do that while we're talking. You scroll over to PRB, which is the probability, and then number 3 says NCR. So you click on that, and then you would put the number 2 in, and then that would tell you, so 4, math, PRB, NCR, 2, and that gives you 6. So there would be 6 different ways that you could arrange those people. All right, but anyway, that's a whole other lesson on combination. So what I was trying to help you understand is what this NCR means. All right, so there was this really cool guy named Blaise Pascal who came up with this triangle called Pascal's triangle. Actually, there were quite a few other people who came up with it before him, but for some reason, this is the one that the United States uses, which is Pascal's triangle. In other countries, they use different people's, but ultimately, it's the same thing. So this triangle you can use it to expand a binomial with any power of n. I don't have the video that you can watch, but I'll post the video of this Pascal's triangle if you want to go find out the history of it, because it is kind of interesting. But this triangle states that this first thing right here would be the 0 power. So if you had x plus y to the 0 power, this is the one you're going to use, this 1. We know anything to the 0 power is 1. Okay, then if you had x plus y to the first power, you're going to use 1 and 1 as your coefficients. So this is what you use for your coefficients. And then what happens here is all of these are going to begin with 1 and end with 1, based on the pattern that we noticed back here. They started with 1, ended with 1. Okay, and then the second number would be what these two add up to give you. So 1 plus 1 gives you 2. And then 1 plus 2 gives you 3, and 2 plus 1 gives you 3. And then 1 plus 3 gives you 4, 3 plus 3 gives you 6, 3 plus 1 gives you 4. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So hopefully you're seeing where I'm getting these numbers from. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. Alright, so I'm just going to fill in the rest of this triangle. I strongly, highly recommend that you do the same. You're going to use this quite a bit, so you probably want to just make a little copy and have it easily accessible for you. Alright, the last one. Now this goes on infinitely, really, but we usually don't do a whole lot past the 11th power. Matter of fact, you probably won't even use all the way down here, but we're going to write it anyway. Oh, I got one off. Hold up. We got 11, 55, 165, 330, 462. Oh, I should have had 462 twice. Then 330, 165, 55, 11, and 1. All right, so this would be the 0 power. This is the first power. This is the second power, third power, fourth power, fifth power, and so forth. So really you can just look at that number, these numbers right here. So if you've got x plus y to the 9th power, you're going to be looking at this row. Okay, now what are we going to do with this? Well, we're going to have some fun. So flip on over, and we're going to use the binomial theorem to expand each binomial. So here we have a 7th power, so I would use this row, and I'm just going to go ahead and write all of those numbers. So I'm going to write 1, 7, leave a little space, 21, 35, 35, 21, 7, and 1. Now you're going to put whatever value is there, here, and whatever value is there, right there. So let me put little plus signs in everything. And then I'm going to put my parentheses around everything. And then in your parentheses, you're going to put your first term. So my first term is x. So x, 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 x. And your second term, you'll put y. So y, 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 y. And then for your exponents, you're going to always begin with 7 and on the first term and end with 7 on the last term. So from here, I just go backwards. So if that's x to the 7th, this is going to be 6, 5, 4, 3, 2, 1, 0. And then we'll start from the end, 7, and go backwards. 6, 5, 4, 3, 2, 1, 0. And make sure they all add up to 7. So 0 plus 7, 6 plus 1, 2 plus 5, they do all add up to 7. All right, and then from here you just do some math. So y to the 0 is just 1, and 1 times 1 is just 1, and so you really only have x to the 7th for that first term. The second term is going to be 7x x to the 6y plus 21x to the 5th y squared plus 35x to the 4th y to the 3rd plus 35x to the 3rd y to the 4th plus 21x squared y to the 5th plus, oh gosh, I'm running out of room, 7xy to the 6th, and then plus y to the 7th, because that becomes 1 times 1. So that's what we would have ended up with had we done x plus 7 times x plus 7, x plus y times 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 x, and you get the point. So 14641. Then you put your parentheses. All right, and then we're going to fill in our x and y, so x, 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 x. Now our y is not y, it's -3. So -3, -3, -3, -3, -3. And then put your powers 4, 3, 2, 1, 0, 4, 3, 2, 1, 0. And then now we'll do the math. So we end up with x to the 4th is our first term. Now this is -3. So what is -3 times 4? It's -12, x cubed. This 3 squared is 9, so 6 times 9 is 54, x squared. -3 times -3 times -3 is -27. So what's -27 times 4? That is -108. And then that gives us x. And then that becomes 1. So -3 to the 4th power is 81. So we end with positive 81. So that one looks a little different because in the other ones, whatever our coefficients were in the triangle, we ended with that. But here we don't, because we don't have an x plus y, we have an x plus -3. So you can use this with anything. It doesn't have to just be x and y. It can be anything. So I'm going to do D with you, and then I want you to pause it and you try to do E by yourself. So D, we've got to the 5th power, so we want to look at that 6th row. So that's going to be 1 plus 5 plus 10 plus 10 plus 5 plus 1. And then our values for our x are 2x. 2x, 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 2x. And our value for y is 1. And then we'll use our powers of 5, 4, 3, 2, 1, 0, 5, 4, 3, 2, 1, 0. And now x to the 2 to the, so remember this is 2 to the 5th, x to the 5th. So 2 to the 5th power is 32. So 32x to the 5th would be our first term. And then this right here gives us 1, so that's not a big deal. 2 to the 4th power is, let's see, 2 times 2 is 4 times 2 is 8 times 2 is 16. So then 16 times 5 is 80. And then that's 80x to the 4th. Plus 2 cubed is 2 times 2 times 2 is 8. 8 times 10 is another 80. And then all of these are just 1, so that's not a big deal. Normally you would multiply those out. And then we got 2 squared is 4 times 10 is 40, x squared. 2 times 5 is 10, x. And then 2x to the 0 is 1, so all of this just becomes 1 times 1 times 1, so plus 1. All right, so I do want you to pause the video, and I want you to try the next one, x minus 2y to the 4th power. So you're going to use that 5th row, which is 1, 4, 6, 4, 1, and plug all of your things in and pause it and come back and see if you get the right answer. All right, so you should have gotten x to the 4th minus 8x cubed plus 24x squared y squared minus 32xy cubed plus 16y to the 4th power. All right, so finding specific terms is a little bit harder. Well, not necessarily. It's just a little different. So let's say you want to look for like the 3rd term of a 5th degree binomial. So instead of having to expand it all out and then finding that 3rd term, there is an actual formula we can use, and it's given here. So to find the term in position R of x plus y to the nth power, we're going to use this combination and then x to the n minus r times y to the r. So you really need to be careful about this part. This is a beware. All right, be careful. The term number is not the same as its position number. The position number r is going to be 1 less than the term number. So if I'm looking for the 4th term, this value right here and here and here is going to be 3. So you're going to use r equals 3. If you're looking for the 6th term, you're going to use r equals 5. So in this case of looking for the 1st term, we're going to let r equal 0. And this 3rd term, we're going to let r equal 2. So be very careful there, because that can mess the whole thing up. So based on the formula, we're going to use this combination. So that's going to be a combination of 5, it's very hard to explain that, but these are the numbers you're going to use in your calculator. So combination 5, 0. And then you're going to put your whatever is in here. So we've got x and negative y. And then the r is your position number, so that would be the 0 power. Therefore, this is going to be 5 minus the 0 power, so 5. All right, so if you put in your calculator 5C0, so again, I'm going to remind you how to do that. You're going to hit 5, math, probability, NCR, 0, and you end up with 1. So that's going to be 1, and then x to the 5th is just x to the 5th, y to the 0 is just 1, so you end up with x to the 5th. That's your 1st term. All right, now that one was pretty easy. I could have done that without doing all of that tricky stuff. All right, so here the 3rd term of a 4th degree binomial would be this 4C2. Okay, you're going to plug in 2m as the 1st term and negative 5 as the 2nd term. Remember your r is 2, and so then 4 minus 2 is 2. And now let's do this. So when you push 4, math, PRB, NCR, 2, that number is 6. So that's 6. 2 squared is 4, m squared, and negative 5 squared is positive 25. And once you do 6 times 4 times 25, you end up with 600. So your answer here would be 600 m squared. All right, sometimes it just asks for the coefficient of that, so in that case you would have only said 600. You just have to see what the problem's asking for. All right, let's try one more together, and then we'll let you do d by yourself. So here we have n equals 4, therefore r equals 3. You're looking for the 4th term of this 5th degree binomial. So we're going to do 5C3. Negative x is your x value, and 3y is your y value. And then the 3 goes here, and then 5 minus 3 goes here. So 5 math in PRB NCR 3, that number is 10. So 10. So if you don't have a calculator, what you're looking for is, let's go over here to our triangle. You're looking for that 5th row and then position number 3. So that's 10. All right. And then negative x squared is x squared. And then 3y cubed is 3y times 3y times 3y. So 3 times 3 times 3 is 27y cubed. And now multiply 27 times 10, so we get 270 x squared y cubed. All right, so pause the video and try to do D by yourself. Okay, you should have gotten negative 17,496 x to the 7th y. If you did not, look at my steps, and that's it. So that was a lot to cover today, but yeah, it is what it is. So that's the binomial theorem, shortcuts to expanding binomials. And your homework tonight is just to study for your quiz tomorrow. Your quiz tomorrow is on factoring and solving polynomials and writing polynomials when you're given zeros. So study for that, and then we'll start doing some homework on the binomial theorem starting tomorrow on Tuesday. So try to keep this fresh in your mind, and that's it. I hope y'all have a great day.